Let's talk about multiplying rational expressions. From arithmetic, we know that we can cancel out from any numerator to any denominator during multiplication of fractions. For instance, if we're multiplying 2/9 times 3/4, we can cancel out either straight up and down, reducing, or diagonally. Not from top to top or bottom to bottom, but we can go from any top to any bottom. So for this fraction, 2 and 4 can cancel out diagonally since 2 goes into 4 two times. 3 goes into itself and into 9 three times. So when we do our canceling, we're left with 1's on the top and 3 and 2 on the bottom. And now all we need to do is multiply straight across. 1 times 1 made 1, and 3 times 2 made 6. So 1/6 is our result. Well, the same thing can happen with algebraic rational expressions. And as with all rational expression problems, we have to factor as the very first step. So as we look at this one, let's begin by factoring. Now, you probably didn't need any help to factor these things since both parts are difference of squares, but I want you to pay attention as we go along in this chapter that you get some help if you look around at other things. This x plus 2 is a prime, and it does not cancel with the x plus 3 that's on the bottom. So if we're going to get rid of this x plus 2, it would have to show up diagonally down here. Is x plus 2 something that could factor this? It is. X plus 2 and x minus 2. Likewise, this x plus 3 did not cancel straight up and down, so if I'm going to get rid of it, it's going to have to happen diagonally here. Is x plus 3 something that could help us with this? It is. X plus 3 times x minus 3. Now we can cancel out the things that match up directly with each other, either straight up and down or diagonally from any numerator to any denominator. This x plus 3 matches that one. This x plus 2 matches that one, and we're left with x minus 3 over x minus 2 as our answer. Notice that I cannot cancel anything else out. The only time canceling can occur is if there is multiplication happening. When there is addition or subtraction, we leave it alone. Let's look at another one. For this one, again, notice how factoring one part can help you to factor the other parts. This x plus 2 is again a prime, and I see that it's not going to help me up above. Is x plus 2 somebody that could help diagonally? It is. X plus 3 would be with it. So our factored form of this part ends up being this. Now I see that x plus 3. Is it something that could help me factor the thing that was below? It is. X plus 3 and x minus 1 will factor the stuff that's below. And notice that that x minus 1 is somebody that helps diagonally over here to factor that difference of squares. So once you get the ball rolling, a lot of times it will snowball and you'll be able to pick up more factors. It'll be easy for you to get things factored once you get any one part going. Now we can cancel out the things that match up directly. The x plus 2 that we noticed first matches the x plus 2 over here. The x plus 3 that we noticed second matches with the x plus 3 below. And then the x minus 1s diagonally cancel out as well. So it looks like the only thing that's left is an x plus 1 on the top. If what you've got left is just on the top, then that's all you need to say, and x plus 1 is our answer. Now, if we had been left with stuff just on the bottom, we can't leave a top of a fraction empty. You have to have a placeholder if that happens. So if the top is empty, stick a 1 up there as a placeholder. But if the bottom is empty, we don't have to do anything. We just put that as our answer. Remember, when you are multiplying with rational expressions, factor everything as much as you can first, noticing if things straight up and down or diagonal to each other can cancel out. You can cancel out things that match up directly from any numerator to any denominator.